All right, topic 9-6, greatest common factor. And you'll notice on the first slide here, I've put a question at the bottom. Why do we need to know how to do this? This is something that will help us as we move on through fractions, with finding common denominators, with reducing fractions. Greatest common factors will help us work with two different numbers and be able to work with them quickly. So we're going to spend just a little bit of time learning how to do greatest common factors. And I will tell you that making factor trees, which is what I'm going to show you how to do in this lesson, has been a favorite of students in the past. It's just kind of a neat way to break a number down. So let's move ahead and see. If you'll notice the top of the page, we have a story about a pet store. A pet store has goldfish and angelfish that have to be put into the fewest number of glass containers. Each container must contain the same number of fish, and each must contain all goldfish or all angelfish. So in order to work this, to figure out how many fish we can put in each container, we're looking to find the greatest common factor of 20 and 30. That will help us know the greatest number of fish that we can put into each container. So I want to start by showing you a simple way to do this is just to list the factors of 20 and the factors of 30. So as I've shown you before, you can very easily just write them down, and I'm going to do 1 and 20. Go ahead through the numbers. 2 goes into 20 10 times, so 2 and 10. 3 doesn't go into 20, so I'm going to skip it. 4 does go into 20, and it goes into it 5 times. And because I'm at 5, obviously I started over because 4 times 5. 6 doesn't go into 20, 7 doesn't go into 20, 8 doesn't go into 20, and 9 doesn't go into 20. So notice there's space here, but that's okay. When you make a long line of factors here, it's hard to know how much space to leave. So the factors of 20 are 1, 2, 4, 5, 10, and 20. Now to do the factors of 30, we know we have 1 and 30. 2 does go into 30, so 2 and 15. 3 goes into 30 10 times, so 3 and 10. 4 doesn't go into 30. 5 goes into 30, and it goes into it 6 times, so we have 5 and 6, and we're finished because we started over. 5 and 6. The next number would obviously be 6, and we've already used it, so we know we're finished. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now, to find common factors, you just kind of line them up. They both have 1, obviously. They both have 2. They both have 5. They both have 10. And that's it. So when I look at the factors of 20 and 30 written out like this, I know the common factors are 1, 2, 5, and 10. But as I look at it, I can also look and see that the greatest common factor of 20 and 30, is 10. So I'm going to show you another way. This is the factor tree part that a lot of students really like to do. First of all, I'm going to skip down here and remind you what prime factors are. Remember, prime factors are factors that only have, prime factors are numbers that only have factors 1 and itself. Okay? So to do a factor tree, you list the number at the top, as you see here, listed at the top, and then you just start breaking it down into multiplication problems until you have all prime factors left. So I'm going to just go to the next page and show you what that would look like with 20 and 30. So I'm going to start, and it doesn't matter what you start with. You can start wherever you'd like. I know 4 times 5 is 20, so I'm going to start with that. The cool thing is 5 is prime, so I'm going to circle it because there's nothing else that goes into 5 other than 1 and 5. 4 is not prime, so it needs to be broken down further. Factors of 4 are 2 and 2. Okay, 2 is also prime, so I know I'm finished with that side of my factor tree. So now I can say that the factors of 20 are 2, 2, and 5. And you always put them in numerical order. Okay, over here 30, I'm going to do 5 and 6. Now I could have done 2 and 15, I could have done 10 and 3. Any of those would have worked. What I try to do is find one that will give me a prime factor first so that I only have to work with one side of the tree. 2 and 3, 2 times 3 is 6. Those are both prime. So the factors of 30 are 2, 3, and 5. Now remember, we list them in numerical order. We don't list them the way we've put them in the tree. Now, in order to know what the greatest common factor is, you have to line them up. So we have 2, 2, and 5 for 20. We have 2, 3, and 5 for 30. Circle the common ones, 2 and 5, and then you simply multiply them to get the GCF, or the greatest common factor. We know 2 times 5 is 10, so how many fish could go into each container? 10 fish. Now if you look back, if you remember back to this page, 10 was our greatest common factor when we did a factor list. So I want you to know that either way is okay. I want you to know how to do both ways. So basically what we did here was we made a factor tree where we broke down each of these numbers into multiplication problems until we had all prime numbers. We listed them, and then we circled the common factors. We multiplied them together, 2 times 5. Not 2 times 2 times 5 times 5. A common factor here is 2. A common factor here is 5. 2 times 5 is 10. And that gives us our greatest common factor for 20 and 30. So let's practice some. Let's make a factor tree for 16 and 42. So I'll go ahead and draw my little beginning branches. 16, I'm going to do 2 and 8 because I know 2 is prime, and that's going to start me off already with a side of the tray I don't have to worry about. Could have done 4 and 4. That would have worked just fine. Let's go ahead and break my 8 down. 2 times 4 is 8. That's prime, so I'm done with that. Now I got to still break my 4 down. 2 times 2. 2 is prime. So, I want you to get in the habit of coming down here after you've done a factor tree and just writing the factors. So we have 2, 2, 2, and 2. Okay? 42. Let's do 6 times 7. 7's prime. Nothing goes into 7 but 1 and 7. Let's break our 6 down. That is 2 times 3. Those are both prime. Notice how I circle them if they're prime. That way I know I'm finished and I don't need to do any more multiplying. Okay, go ahead and write your 42 under here. This just makes it really easy to have them already lined up. 2, 3, 7. Here you can look and see that there's 2 is in common, but there's nothing else in common. So the GCF of 16 and 42 is simply 2. Remember, it's not 2 times 2. It's just simply 2. You have one group of 2. So the GCF is 2. Okay? What is the greatest common factor of 9 and 12? Well, it's asking us to do the GCF of 9 and 12, so let's break 9 down and let's break 12 down. 9, 3 times 3. And guess what? Those are both prime. So that was an easy one. Go ahead and come down here and start listing your factors. 3 and 3. 12, I'm going to do 3 times 4. 3's prime, 4's not, so I got to keep going. 2 times 2. And those are prime. So my factors of 12 are, remember doing in numerical order, 2, 2, 3. What do they have in common? They have 3 in common. What is the GCF of 9 and 12? It is simply 3. Not 3 times 3, but just simply 3. Okay, I want to erase this and show you if we had done the list, because you can still do the list if you would rather, if you're not asked to do a factor tree. So let's say we had 9 and we had 12. Let's go ahead and do the factors for 9. I know 1 and 9 are factors, and I know 3 times 3. And I'm finished because I've repeated myself 3 times 3. 12, I know I have 1 and 12. I know 2 and 6 are factors of 12. And I know 3 and 4 are factors of 12. So if you look at the common factors, You're always going to have 1, so you don't even really need to count that one. 3 is the greatest common factor. 3 is really the only common factor. So your GCF of 9 and 12 is 30. Okay, moving on. Let's make factor trees for 7 and for 28. Now 7's pretty simple because 7 is just 7 times 1. Those are both prime. Typically we don't need to include 1. 28 is 7 times 4. 7 is prime, so let's break 4 down. 2 times 2. Now let's write it out. 7, and I'm gonna omit the 1. We're just gonna do 7. And then 28 is 2, 2, 7. Remember, we put them in numerical order. Here is my common factor. So what is the GCF? It is 7. Okay? Hope you're getting the hang of how to make a factor tree. They're really not hard at all. What is the GCF of 20 and 45? Okay? Remember, you can start wherever you want to for your factor tree. I'm going to start with 2 times 10 because I know 2 is prime and I can be finished with that side. 10 would be 2 times 5. Those are both prime. So let's go ahead and start our list down here. 2, 2, 5. 45, I'm going to do 9 times 5. 5 is prime. 9 needs to be broken down a little bit more. It's not prime, but 3 times 3, those 3's are prime. So my factors for 45 are 3, 3, 5. Here is my common factor. So the GCF for 20 and 45 is simply 5. Okay? Let's practice one more. GCF of 18 and 42. Now, in case you haven't figured this out already, if you know the GCF of 2 numbers, the greatest common factor of 2 numbers, it's going to make simplifying fractions so easy for you. Yes, we can simplify fractions and keep going and keep going and keep going until we get it down to prime numbers. Or if you start with the GCF to begin with, when you're reducing, it takes a lot less work on reducing the fraction. So I did want you to know there's lots of benefit of knowing how to find a greatest common factor. All right, I'm going to do 2 times 9. 2's prime. 9 breaks down into 3 times 3. There we go. There's my 18 done very quickly. Let's go ahead and list that. 2, 3, 3. 42. I'm going to do 6 times 7. 7 is prime. There's nothing else that goes into 7 but 1 and 7. And then 6 is 2 times 3. Those are both prime. So my list for 42 is going to look like this. 2, 3, 7. Now let's circle what's common. So I have 2 and 3. So to find my GCF, I have to multiply 2 times 3. And that becomes 6. So the GCF of 18 and 42 is 6. So the big thing you need to remember when you're doing factor trees and you're listing them, if you have more than one group circled, all you do is multiply them together. Not 2 times 2 times 3 times 3. 2 times 3. You have one group of 2, you have one group of 3. Now I want to show you just really quickly how this would have looked different if we had simply made a list. So 18 and 42. Okay, so if I want to make a list of factors, I know obviously 1 and 18. 2 goes into 18 9 times. 3 goes into 18 6 times. 7 doesn't go into 18. 8 doesn't go into 18, and there's 9. So we're done with 18. 42. 1, 42. This is a large number, so I'm going to leave myself room just in case. 2 goes into 42 21 times. 3 goes into 42 14 times. And if that's something you don't know, just come over to the side and divide it out. 4 doesn't go into 42. 5 doesn't go into 42. But 6 goes into 42 7 times. And I'm finished. So, to find the GCF of these two, I'm just going to pair them up. Just all my common factors first. Lots of common factors with these two numbers. And that's it. None of these match. So my GCF is 6. And if you remember back when we did the factor tree, we ended with 2 times 3, which was 6. So the GCF will work either way. Like I said before, I want you to know how to do both ways, both with a list and with making a factor tree. All right, so here is what I'd like you to write on your notes page. In part 1, if you will make a factor tree for me for 12 and 14. Set your paper up in that section like I've been modeling, like I've been showing you here. Numbers here and here. And go ahead and make your tree for me for those two numbers, 12 and 14. Part 2 asks, what is the GCF of 24 and 56? I'm going to give you two choices. You can either do the list of factors for 24 and 56, or you can do a factor tree. Whichever one you like the best, you're still going to be able to come up with the greatest common factor. So your choice what you do on part 2, but I would like for your final answer to show me what is the greatest common factor of 24 and 56. And then part 3 in your notes page today, explain to me how you make a factor tree. What are the steps that you need to do? What happens at the end of a factor tree? Make sure that you explain about listing and how important it is to list the factors in a factor tree. When you come to class tomorrow, we'll be working with factor trees and greatest common factors. If you had any trouble with understanding how to do either the list or the factor tree, please go back in the video and watch a couple of the slides. Watch me do it once again, just to kind of solidify in your mind how this is done. I'll see you in class tomorrow.